So let's start the next unit. First of all, let me check the video is starting or not. Yes, the video is starting properly. Okay, so the unit 2 of UML means object oriented analysis and design. This is the main subject, and his the unit of second unit which is basic structural modeling. First unit, which is introduction to UML, that we covered in our channel, and that video also available in our channel in the live section. Then we are going to discuss the second unit of object oriented analysis and design using UML. So the topic is subtopic. This is basic structural modeling, unit 2. Okay, so here we will discuss some topics of this main topic. Okay, this unit introduces fundamental concepts for modeling structure, modeling the structure of a system using the UML. Unified UML means unified modeling language. Okay, so here we will delve into the first part, basic structural modeling. Okay, so topic 1, which is classes means real life example. Let's take, imagine a library A. Okay, a library A, library okay, imagine a library. Okay, we imagine a library where a book class could represent the blueprint for individual books. Okay, capturing their attributes like title, author, ISBN, and genre. Okay, then each book in the library would be an object of the book class, sharing the same characteristics but having unique values for its attribute. And in this topic have some questions, you can note down it and solve it yourself by yourself. Okay, so first question is, what are the essential attributes and behaviors of a book object? Okay, then second question, how can the book class be used to model other real world entities, example movie, song, etc. Okay, so you can note down these questions and solve this question by yourself. Then topic 2, is relationships. Relationships mean real life example. In the library, a book object can be borrowed by a member object. This relationship can be modeled using an association in a UML diagram, showing the connection between these classes. Okay, then types of relationships. Association, a connection, association. Okay, so in association, a connection between objects, example book, can be borrowed by member. Okay, then aggregation means has a relationship, example a car object has a engine. Okay, object. Then inheritance means a subclass inherits attributes and behaviors from a superclass. Example, a sports car class inheriting from a car class. Okay, then also have this topic some questions which are, what first question is, what type of relationship would exist between a student object and a course object if a student can enroll in multiple courses? Then the second question, how can library member, example student member, uh, uh, faculty member, okay, etc. So you can note down this question also and solve it by yourself. So now we need to go to the next topic by saying next. So the next topic is common mechanisms. Common mechanisms. Okay, then in UML, several mechanisms help refine how classes and relationships behave. Okay, so first of all, multiplicity. Multiplicity. So in multiplicity, specifies the number of objects involved in a relationship. For example, a student object can be enrolled in one to many course objects, while a course object can have many to many student objects enrolled in it. Okay, navigability. Navigability. Okay, in navigability indicates whether one object can navigate the relationship to access the other. For example, in a student course association, both might be navigable, allowing a student to see their enrolled courses and a course to see its enrolled students. Okay, then visibility. Visibility means defines the excess level of an attribute or operation with a class. Public attributes are accessible from anywhere, while private ones are only accessible within the class itself. Okay, then a real life example. Let's take this example. Okay, in this example, consider a shopping cart system. Okay, a shopping cart object can have one customer object, okay, associated with it one to one relationship. The customer object can navigate the relationship to access its shopping cart. Navigability, the shopping cart might have a private attribute named items to store the list of products accessible only within the class itself. Visibility. Okay, also have this topic some questions. You can also note down these questions also and solve it by yourself. First question is, how can multiplicity be used to model a relationship between a movie object and its actor objects? Okay, one movie can have many actors and one actor can be in many movies. Yes, this is the real life questions. Okay, then why, the second question, why is it important to define the visibility of attributes and operations within a class? Okay, so let's go to the next topic. So next topic is coming up. The next topic is advanced structural modeling. Advanced structural modeling. In this advanced structural modeling have advanced classes. Okay, advanced classes. So what is advanced classes? Advanced classes build upon the foundation of basic classes and introduce additional features for more complex modeling. First of all, abstract classes. Abstract classes means define a blueprint for subclasses but cannot be directly instantiated as object. Okay, they act as templates for specialized classes that inherit their properties. Okay, then stereotypes. Stereotypes means provide additional meaning or context to a class. For example, the stereotype utility might indicate a class meant for reusable helper functions. Okay, then let's take a real life example, which is imagine an e-commerce system. Okay, I imagined. Okay, then an abstract class product could define common attributes like name, price, description, applicable to all products. Okay, specify specific product types like book, electronics, and clothing would then inherit from product and add their own unique attributes and behaviors. Okay, I also have in this topic some questions. First question is, how can abstract classes be used to model different types of blank bank accounts? For example, checking account, saving account, sharing common attributes like balance but having distinct functionalities. Second question, when might it be appropriate to use stereotype in a UML model? So you can note down these questions and solve it by yourself. We now we will go to the next topic by saying this next. Okay, the next topic is advanced relationships. Okay, they are these relationships go beyond basic associations and offer more nuanced nuanced ways to connect classes. Okay, first of all, generalization means inheritance. We have already discussed this in basic relationship. Okay, but it's worth returning. Okay, a subclass inherits properties from behavior and behavior properties and behavior from a superclass, allowing for code reuse and specializations. Okay, understand. Then specialization. Specialization means the process of creating subclasses that inherit from a more general superclass, adding specific characteristics. Then aggregation. Aggregation means composition, the alternative word. Okay, so what is aggregation or composition? It means has a relationship where the whole means containing object is responsible for the lifetime of the part contained object. If the whole object is destroyed, the parts uh, are also destroyed. Let's take a real life example of it. So consider a car manufacturing company. A car class might be the superclass, and sedan, SUV, and truck could be specialized subclasses. Okay, inheriting general car attributes like engine, wheels, and adding their own specific ones like seating capacity, cargo space. Additionally, a car object could aggregate an engine object, meaning the car object manages the life cycle of the engine object. Okay, then also this topic has some questions. First question is, how can the concept of specialization be used to model different types of electronic devices, like example laptop, smartphone, tablet, etc., all inheriting from a common electronic device class but having unique functionalities. Okay, then second question is differentiate between aggregation and association with using an example. Okay, you can also note down these questions in your notebook and then solve it by yourself. So we will go to the next topic by saying just next. What is the next topic? The last topic of this is packages, types and rules, then packages. Okay, next topic, interfaces. Okay, next, wait for its response. By the way, we use Gemini to study this subject. Gemini is made by Google. Okay, so great. Let's move on the next topic in advanced structural modeling, which is interfaces. Interfaces means interfaces in UML. Selecting from this area, not fully. Yes. Interfaces in UML defines constructs that specify what functionalities a class must provide without detecting how those functionalities are implemented. This promotes what? Loss coupling. Loss coupling. Loss coupling means classes implementing an interface does not need to know the inner workings of other classes that also implemented the same interface. They just need to know the functionalities offered by the interface. Polymorphism. Polymorphism means different classes can implement the same interface in different ways, allowing for flexible and interchangeable behavior. Okay, then let's take a real life example on this topic, which is imagine a music player application. A music player interface could define functionalities like poly, play, play, pause, and stop. Different music player implements like MP3 player, streaming player could implement the music player interface, providing their specific ways of playing, pausing, and stopping music while adhering to the defined construct. Okay, uh, so let's discuss some question. How can interfaces be used to model different shapes? Example: circle, square, rectangle, triangle, that all share a common drawable interface requiring them to implement a draw method. Okay, then the second question: what are the advantages and disadvantages of using interfaces in object oriented design? So you need to note down these questions and solve it by yourself. So we need to go to the next topic. So let's go to the next topic. It's coming up for us. Let's wait for it. Basic behavioral model. behavioral model in our FSS. Types and roles. Uh, I I think you just gauge TOPIC of unit 2. Okay, what response will come? Let's see. You're right. Okay, so the topics, types of roles, types and roles. Sorry, types and roles. So types mean these represent different variations within a class. Imagine a shape class. You might have different types like circle, square, and triangle. Within the shape class, each with its specific properties and behaviors. Okay, then roles. Roles means these define the specific responsibilities or behaviors an object takes on within a collaboration. For example, in a library management system, a book object could play the role of a loanable item. Okay, when being loaned out to a member. Okay, then let's take a real life example of this topic, which is consider a social media platform. Okay, considered. Then a user class might exist, yes, with different types like admin, regular user, and business. Yes, okay. Each type inherits from the user, okay, class, but has specific functionalities. Yes, you're right. Okay, then additionally, a user object could play the role of a content creator. Yes, yes, yes. When posting comment, or a follower when following other users. Right, I understand. Then the next topic is packages. Packages means these serve as a way to organize and group related classes, interfaces, and other UML elements. Means packages helps manage complexity and improve readability in larger projects. Okay, real life example. So in an e-commerce application, you might have separate packages for com.ecommerce.products, okay, containing classes like product, category, and inventory. Then com.ecommerce.users, containing classes like customer, seller, and administrator. Okay, remember. Okay, what is the remember? These are just introduction to each topic. There might be additional details and nuance covered in your specific course material. Okay, so I think we covered the second unit also. Second unit, last topic is packages. So we covered the second unit of this subject, object oriented analysis and design using UML. So this is video for that end of this video now, and we will back with the next topic, which is unit 3, class and object diagrams. Okay, so for that, stay healthy and stay tuned, and thanks for watching the video till the end. Thank you again.